Good evening everyone. My name is Tanuj Jain and I have made a project named Shopper's Preference. Project is unsupervised machine learning and contribution is individual. Project summary. The Shopper's Preference is an e-commerce analysis solution that segments customers using RFM clustering and recommends similar products via item-based collaborative filtering. The GitHub project link is there and project link is there. Uh, this is the problem statement. E-commerce platform often struggle to understand customer behavior and provide relevant product recommendation. Without clear customer segmentation, marketing efforts become inefficient. Additionally, lack of personalization recommendations can reduce user engagement. For this, we have made this project which will help the businesses to recommend products to new customers. Know your data. Here we are importing our libraries. I am restarting the kernel. Restart kernel only. Okay, the kernel restarted. Now, first I am importing libraries. All the libraries are imported, and then I am loading the dataset which I have been provided. This. Now, first look of data. Okay. Here we have 8 columns and shape of columns and rows 54909 rows and 541909 rows and 8 columns. Okay, describing dataset. Count 541909 as we have seen. Mean of the data 25%, 50%, 75%, max 80995. Okay, the first one data set is structured. Okay, dataset cleaning. Here I am cleaning the dataset. I am dropping null values for customer ID and description. Here I am invoice where the invoice is cancelled. Uh, we have seen that the cancelled invoices are start with C, so we are removing the invoice number which have C in initial characters. Where quantity is greater than 0 and unit price is greater than 0, we will only use those invoices. DF total price equals to quantity into unit price. Okay, now we have added our new column total price. DF dot head. Now we are describing. Here we can see dropping null values and after data cleaning the rows reduces and the column increases. I have to add one thing also. Not sure. Here we can see there are now 9 columns. What is this? Okay, here we have to add EDA. EDA. Here we are making some plots for dataset. Here the number of transactions per country. We can see United Kingdom have the most transactions in our dataset, then Germany, then France. Okay, then all the okay. Top 10 products by sale volume. Here we can see the most sold product. Papercraft Little Birdie is the most selling product in our dataset. Medium ceramic top storage jar is second one, and World War II glider assisted designs. Okay, it is third one. Then we are top 10 products by revenue. Papercraft Little Birdie Regency cake stand 3 tier, and then white hanging heart tea light holder. Okay, and sales over time. Here you can see the sales increases in the winter season, September to December. And then RFM preparation. Here we are preparing our RFM values, uh, where the invoice number will be unique, total price will be a sum, and then invoice data will be lambda x snapshot plus ax mx. Okay. Now, how that RFM table will be shown, a sample. Then we are printing the head of RFMDF, recency, frequency, and monetary. Okay. Fig X. Okay. Here we are plotting RFM distributions. Here we can see recency is great, left skewed, and frequency is left skewed, and monetary is also left skewed. Okay. Column correlations. Here we are uh, checking for correlation of unit price and total prices. We can see if the quantity increases, then total price increases. If unit price increases, then also total price increases. And when total price increases, okay. This is our correlation map for RFM. Here we are adding some features, latest date, RFM group by. Okay. Here we are using standard scaler for scaling the data set for a great fit. K means clustering. Here we are getting our clustered values, labeling clusters, depth flex segment. Okay, this is here we are making a function which will label the clusters on the basis of the table provided in the problem statement. Saving model. Here we are saving our models and CSV file which we have made. Here we are saving k-means model, a scalar model, and RFM dataset to CSV and main dataset to CSV. Okay, collaborative filtering. Here we are making item matrix, user item matrix, then product similarity matrix, then similarity DF. Okay, we are here saving our product similarity CSV, mapping the product. Here we are mapping we are making our product map. Here in this variable in this dictionary we will store code to name, and in this dictionary we will store name to code in key value pair. These are helper functions which will help us to get the similar products. Okay, closure scrolling. Okay, def get to 5 similar, then here we will get 5 similar products. Is an example usage. Here is a wide hanging tea light holder, kernel sales. Now here we are clear slide output. Okay, here we are checking our models and the data set. Here we are giving an white hanging heart tea light holder. Then we are getting 5 recommended products. Then now I will take black and cat bar. Here we can see from black and white cat ball we will where the customer can also buy the dog bowl, potting shed candle, citronelle. Sorry, potting shed rose candle, doorstep at spot heart, and cast iron hook garden fork. Now we will see our project. Here, when we enter any product, here I have made a select from list because it will recommend products also. For DURLY Dolly Girl Children Bow. Okay, recommend products. Here it is recommending children cup, space for children cup, blue bunny Eastern egg basket, pink bunny Eastern egg basket, paint your own egg in crate. Okay, customer segmentation. Here you can see in days. Now we can see 23, frequency of number purchase only 5, monetary total spend estimatedly 5630. Okay, predict customer. Now we can see in 23 days the customer has made a 5 purchases with an overall value of 5600. Then now we can see if we increases the date, example 365 days. Now we will also change this. Okay, very customer. Now we can see this is an occasional customer, and we can also add high monetary gain for. Okay, this is a regular customer because it has spended so much amount but in a little orders. Now if we change our number of orders, we can easily see it is an occasional customer. Now for 5 credit customer, it is regular customers.